Okay, welcome back. I have a green LED now. Found that in my parts bin. And the part list says we should have a blink PCB, 3-volt battery, that's the 2032, LEDs red, green, and blue, 3 resistors, a push button switch ×3, and a battery holder. Okay. Guess what? No instructions. Don't freak. I'm going to take the circuit board, and I'm going to put this in the holder. Actually, I will do it this way. Whoops. Pardon me. Trying to get the circuit board to fit in my holder. This is, zoom back out a little bit. Oh my dummy. This little circuit board holder, I can figure out what the hell I'm doing, is about $8 on Amazon. It's basically a rotisserie style. You can adjust the way it holds the circuit board and everything else, and it allows you to spin the board around from one side, and you can flip it over to make soldering joints on the other side. Really simple. Highly recommend one of these. They're very inexpensive. Okay, since there's no instructions, what I'm going to do here, get my components. This is very, very simple. Put my components over to the side, and I will zoom in so that you can see what I'm doing. Okay, so we have R1, R2, R3. First thing I want to do is, I'm kind of anal about this, is I want to clean off the circuit board. So I am going to use some 99% isopropyl alcohol, and I'm just going to clean off the board to get the manufacturing junk off of it. And flip it over on the other side. Clean these. Sorry if some stuff is out of frame, but I'm just using a medical grade isopropyl alcohol. You can find it on Amazon. You don't have to use it. You can use whatever you can find at a drugstore, like the 70% or 90% or 91% isopropyl alcohol. I prefer to use the 99% because it's almost pure isopropyl alcohol. The 70% stuff you find at the drugstore is 30% water. So why are you spending money on buying deionized water? I don't know. Okay, so let's flip this puppy around. All these resistors are the same value. So we got, oh heck, I can't even read these things. Bear with me. Where'd my test meter go? Oh, there it is. I'm going to zoom out a little bit. Bring in my $20 Anang 8008 digital multimeter. When I get started in electronics, I'll do a review on this. This is a good little meter for the price. Let's set it to resistance. We're on megohms. Okay, we're good. So let me get my cable out of the way. I'm sorry about that. Yeah, I'm not the best YouTuber out there. I just kind of wing things. I don't have a script. I don't... Fuck. Yeah, these are 200 ohm resistors. Okay, yep, it's good enough. They're all three the same, so we're gonna put the meter back over here. And what I like to do is just cut the paper ends off. That way you don't get glue and crap in your circuit board. And we will zoom back in. So R1. What I'm doing is I'm just forming the leads with my fingers. Bend it over like that. Bend that one over like that. Oh, sorry, it's getting out of focus. Basically, you just want something like that, and they will fit right in to the sockets. Now, resistors are not polarized, so they can go in any direction. Doesn't matter. I will push these in like so. Oh, they're a tight fit. I will take the next one and form them. You don't need fancy forming equipment, but I like to put all these resistors in the same way that you would read them. So the brown band will go up. Like so. Same with this one. Zoom back out a little bit. Put that into R3. A lot of these a lot of these kits don't have instructions, but they will have what's called a bill of materials, or BOM, and they will have the values on them and where they go on the circuit board. But this is a very basic circuit, so we will just smush these in here. Like so. A lot of times if these resistors don't want to play well, you can use a pair of needle nose pliers and just pull up on the leads gently, like that. And I just give them a little push out like so. Hold them in place using my thumb to hold them tight against the circuit board. Now I'm going to use MG Chemicals 0.032 diameter, 22 gauge, 2.2% flux, which is a 63% tin, 37% lead. This is a eutectic solder. All I do is I pull off maybe a foot, cut it off the spool because I don't want to poke around holding a heavy ass spool of solder. Take my iron, I'll give it a clean in the brass wool, and I will just put a little kiss of solder. Can you see that? Oh, there we go. I'm just going to put a little dab of solder on the tip. That helps with transfer. Put that on the pad and the leg and feed in the solder. Easy peasy. Oh, I'm completely out of frame. Sorry about that. Let's try this one. Put your iron on the pad and the leg. Feed in a little bit of solder. Let go of the solder, then remove the iron. On with the iron. Flow in the solder, then release the iron. I'll clean it off in the brass wool. And now we will work on the other two legs. So I'm going to move those out of the way here so you can see them. About every couple of joints I clean the iron off in the chip cleaner, the brass wool, whatever you want to call it, and then give it a little bit of solder on there to help with the heat transfer, and then feed in the solder. Very easy to do. Heat the pad and the lead, flow in a little bit of solder, let the solder go, then release the iron. That one looks a little stupid. Try it again. There we go. If you make a mistake, you can always reflow it. And then got too much solder on the tip. Little dab will do you. And then flow it in like that. See how nice and shiny those are? That's a good joint. Then you want to cut the leads off. Well, here's where a little, I've seen so many YouTubers, they just cut them off. Hold the leg. Then bring your cutters in. That way they're not flying all over your workbench, into your eyes, everything else. That. I think it's pretty easy. If you chop off a little bit too much, say you cut into the solder joint like I did over here, you just come in with your iron, reflow it a little bit, just give it a little touch. Boom. Actually makes for a neater looking joint. Nothing wrong with it. Okay, so the resistors are soldered in. Now, you always want to do the resistors first because they're lowest to the board. It's easier that way. Lowest components in first, then the taller ones come in later. Now we got to do the LEDs. So we have L1. I'm going to use L1 as the red LED. Positive leg is the long leg. These are polarized, so they have to go in the exact right way or else they don't work. The cathode is the short leg. And on most of these resistors, the negative end has a flat spot right here. I don't know if you can see that, but it is a flat. And says the cathode. The way I was taught in electronics school is A+, C- for diodes, because the anode is longer, and if you cut that off you can make a little plus sign, and the cathode is the negative, so it was always taught to me A+, C- for diodes. LED is a light emitting diode, and since there's no instructions on this circuit board, you can see L1, there's a flat spot that designates the negative. The positive, or the anode, is a square pad, whereas the cathode is a round pad. So we will put this long leg into the square, and that'll match up with the flat spot. And then you spin it around and you bend the legs out just a wee bit. You don't want to bend them out too much, because if you have to come back in later and replace them, it's a bitch if they're clinched over. Now the second one, we will put in the green LED. Again, exact same thing. Positive leg, long leg goes in the square. The short leg goes into the round. Flip it over. Bend the legs out a little bit, just to hold them in place. And then we will slide this down a little bit. And the blue one, again, these are straw hat LEDs, everything's the same. Long leg in the square, short leg goes in the round, and the flat spot will line up. And most circuit boards are just like that all the time. So, again, clean the iron. We'll touch of solder for heat transfer. Heat the pad on the leg. Pad on the leg. Flow in a little bit of solder. Now this 6337 is a eutectic solder, so it melts and solidifies at the exact same... Shit, that was a stupid joint. Let's try it again. Kind of hard working under the camera. There we go. So this stuff solidifies and melts at 183 degrees centigrade, or 361 degrees Fahrenheit. And gives you a nice quality joint. That one didn't have enough solder on it, so I'll feed in a little bit more. Uh-oh, we have a solder bridge. Right here, solder's bridge between the two. Easy way to fix it. Put your iron in there, flick it. All gone. Okay. Whoops. Cut one a little too short. Make it look nice and neat. Like that. Same way with that one. A lot of people like to do this. They cut the leads a little bit short, then reflow some solder on them, and they look like nice little polished balls. Okay, those joints are looking pretty good. Next up are the switches. These will only go in one way. So we will put in the switches like so. Forgive me, this is the first time I've built this kit. Just have to get them lined up just right, and they will fit in nice and tight into the pads. If they don't, you just got to turn them around a quarter of a turn. Nope, that one goes in like this. Oh my goodness. Sometimes they just don't want to cooperate at all. That one goes in. Sometimes you just have to bend the legs a little bit. There we go. All three of those are in. And again, we just solder them in. Get that back into frame. Sorry about that. A little touch of solder. Oh, need more solder. Yes, I'm from the United States. We don't pronounce the L in solder. And here in Central Florida, it's 95 degrees outside with 48% humidity, and the heat index right now is about 103. So it's a good day to enjoy a cold beverage on a Sunday afternoon. Now what I'm doing is I put the soldering iron tip on the pad and the leg, let it get hot, flow in the solder from the opposite end, because solder flows towards the heat source. It's just the way it works. Release the solder, then the iron. And you will get a nice, neat joint, like that. Okay, and the last thing we need to do is put on the battery holder, and where's that? There it is. These generally go in like so. And on these, you just want to give the legs just a little bit of a bend. A pair of needle nose pliers works well. Or you can just smush them a little bit carefully, like that. And And these are a little bit bigger pads, so it's going to take a little more solder. Let me get that back into frame. And we're going to solder that pad. Release this pad. Flow on the solder. Release. And this one. Soldering is all a matter of feel. You just know how much solder you need to flow into the joint. You'll see it flow and you know when to pull it away. Okay, that's that. Let's see what the hell this kit does. Now on these battery, positive is usually up, like so. Red, green, blue. It's not a bad kit. You don't even need to go to their website and download their instructions. I'm gonna clean off my soldering iron tip. Give it a little kiss of solder. Put it back into the iron holder and turn it off. That's how you preserve your tip. I hope you enjoyed that. I apologize, I'm not the best cinematographer. Sorry, it's bones in there. Neat little kit, about 12 bucks on Amazon. Basic 101. I'm going to do some more basic soldering tips here within the next week because I'd like to show you how to do proper wiring joints, things like that. Union splice, lap splices, mesh splices, whatever you want to call them. Let me zoom out a little bit here. I'm just cleaning up my mess. It's one of the reasons I recommend putting your finger over the leads when you cut them so they're not shooting all over the house or your lab, wherever you're going to do your... Sorry about that, I got the hiccups. Wherever you're going to do your electronics projects. Now, not a bad little kit. And you can see, let me zoom in a little bit here. Oops, wrong way. I'll get used to this damn camera one of these times. I don't know if you can see it, but there's flux. See that shiny, looks like goo here and here and here? That's the flux. Most modern solders, you can leave that flux on there. I'm using MG Chemicals. It's an RA flux, which is rosin activated. And yeah, it's fine to leave it on the board. It's not going to hurt anything, but if you're looking for perfection, what I'm going to do is 99% isopropyl alcohol in a safety dispenser here. And I'm going to take one of these, one of these horsehair acid brushes. You can buy these at a hardware store and they're like a nickel a piece because it's just a piece of stamped steel with a bristle. I cut the bristles off to make them shorter, a little more stout. I'm using the safety dispenser to get some alcohol on that. And I'm going to use a chem wipe, which is a low lint. And I'm just going to take 99% isopropyl alcohol and rub it all over the board. Get that flux off. Just makes it a little more presentable. And yeah, the flux can be corrosive. And I'll take, these Kim Whites are nice because they're a lot tougher than toilet paper. And you can just go in here and blot them like that. I'm sorry if I'm straying out of frame. I'm not used to doing videos. I'm used to just working on electronics. And most of the flux is gone. I'm going to show you a little home gamer tip. Let me find my... When you clean your boards off with alcohol, it tends to leave a little bit of a haze. This is a surgeon's nail brush. It's got nice soft fluffy bristles on it. And this is what surgeons use when they're scrubbing up for surgery. They just, you know, clean their nails, and it's got a little section here to really get in there. When you use isopropyl alcohol, it leaves a haze on there. You just take this little brush and it gets 99% of that crud off there. And this little kit is kind of cool because you got very easy to use. You can go online and get their detailed instructions, but I thought I'd show you some of the basics when you don't have instructions. Low components first, which are resistors, and these go in any which way. Doesn't matter, they're not polarized. The LEDs are polarized, so you got to make sure the flat spot is, most of these kits have a flat spot shown on the silk screening, or the positive will be a square via and not a round via. The switches, they only fit in one way, and the battery holder. And let me clean some more, because this flex is sticky. This may not be a RA flux, this may be an RMA. Rosin mildly activated. Either one is fine to use. Most of these kits, I prefer to clean the board before I solder on them and then after I solder on them, because I don't like sticky, period. Isopropyl alcohol is great because it dries clear and it's not going to short anything out after a second. Just be really careful if you get this 99% isopropyl alcohol, because it is freaking flammable. It, what the hell was that? It burns with no color. You can't tell if you're on fire or not. You'll feel it, but just make sure not to have open flames and things like that. Well, hopefully this helps. I'm going to do a couple more kits here later and some more soldering techniques. I just haven't had that much time. My wife recently retired from the office that I work at, and it's been kind of a shit show. So hopefully here in the next couple weeks I'll be doing at least a weekly video. I appreciate y'all watching. I am not sponsored. I don't care. Anything I have on my show I buy myself, so I'm not sponsored by anybody. And everything I buy, usually on Amazon. And if you have any questions, leave me a comment in the doobly-doo down below, and I can help you out as best as I can. I am no professional. I'm not an electrical engineer. I've just been soldering and went to electronic trade school back in the 80s when we did everything through hole and analog multimeters, and I've enjoyed it. It's a hobby. It's fun for me. But I've learned a lot. And there's other YouTubers that are elitist and say, well, you got to buy $1,000 Urson soldering station, or a Metcal. No, not me. You can buy a $25 analog soldering station, because I prefer that, because I can just bump it up. I've got a Heiko 888D, which I love to death, but changing the temperature on it's a pain in the butt, because it's like a 1980s alarm clock or a microwave oven. I prefer just to be able to twist the knob to go from 600 to 650, 700 degrees Fahrenheit. I've got a couple other soldering irons that I'll demonstrate. I got a Pine-Sol, which everybody is saying is the shit compared to the TS100s. It's cheaper, it's open source software, so you can modify it. I'm just waiting on some power supplies to come in to run that, because it's USB-C and it needs quite a bit of current. It's like a 65 watt. I've got some desoldering tutorials I want to do. You don't have to spend a whole lot of money to get into desoldering, and I'm going to be testing some different kinds of fluxes and you name it. I'll probably have it here on my bench, and we'll test it and give it an honest review. Well, thanks for watching. You all have a great Sunday afternoon. Bye-bye.